Hello and welcome back to We Dared Chemistry. Today, we're diving into a detailed problem from Class 11 Chemistry, Question 2.5. We'll calculate the energy of each of the photons which, I, correspond to light of frequency 3x 1015 Hz to STU, have wavelength of 0, 50A. Here's the question we'll be solving. Solution. Energy of a photon is equal to Planck's constant multiplied by frequency. Planck's constant is equal to 6.626 times 10 to the power of negative 34 joule seconds. Frequency is equal to 3 times 10 to the power of 15 hertz, which is equal to 3 times 10 to the power of 15 per second. Therefore, energy is equal to Planck's constant multiplied by frequency, which is equal to 6.626 times 10 to the power of negative 34 joule seconds, multiplied by 3 times 10 to the power of 15 per second, which equals 1.986 times 10 to the power of negative 18 joules. Energy of a photon is equal to Planck's constant multiplied by frequency. Note: the math processing error likely indicates a missing or incorrect part of the mathematical expression. Planck's constant is equal to 6.626 times 10 to the power of negative 34 joule seconds. Speed of light is equal to 3 times 10 to the power of 8 meters per second. Wavelength is equal to 0.5 angstroms, which is equal to 0.5 times 10 to the power of negative 10 meters. The energy, E, of a photon can be calculated using the equation where Planck's constant, 6.626 times 10 to the power of negative 34 joule seconds, is multiplied by the speed of light, 3 times 10 to the power of 8 meters per second, and then divided by the wavelength, 0.5 times 10 to the power of negative 10 meters. The result of this calculation is 3.98 times 10 to the power of negative 15 joules. That's all for today. If you found this video helpful, please like, share, and subscribe to We Dared Chemistry for more educational content. Have any questions or want to learn more? Leave a comment below. Thanks for watching, and we'll see you in the next video.